invite my principal, Dr. Mohammed Aslam sir, to inaugurate this webinar. Aslam sir, kindly inaugurate this webinar, sir.
Okay, thank you. In the name of Allah, most beneficent and merciful, I deem it as a privilege to inaugurate this one-day international web conference organized by Dr. K. Samim Rani, Associate Professor and Head, Department of Zoology, Mukesh Shah Sarguru Akboard College. The learned speaker and resource person of this international web conference, Dr. R. Vijay Kumar, Professor, Department of Biology, Majma University, Kingdom of Saudi Arabia. Faculty members of Zoology Department of our college, and my dear participants of this international web conference. I would like to extend a warm welcome and extend my greetings to all academicians from all over the world participating in this web conference. The theme of this web conference is Impact of Airborne Fungi, Bacterial Endotoxin Exposure and Respiratory Infections. I am confident that the resource person will shed light on the topic, and I hope his in-depth knowledge is highly beneficial to all the participants of this web conference. This web conference will be highly useful in the present scenario of outbreak of coronavirus pandemic, which has caused problems in the functioning of all countries of the world. Health, medicine, education, business, economy, etc. is affected badly. The governments of all countries, institutions, doctors, experts, academicians are working together on the construction of a new path for the future in accordance with the present scenario. The disruption in continuity of education has presented among teachers and prospective torchbearers very natural concern for the future. Every aspect of local and global education suffer from the crisis of COVID-19. As governments are trying to revitalize society and resume business, educational institutions, universities and colleges will also gradually reopen their campus to begin the normal teaching learning process. Today, widespread use of technology has become necessary for education. Online teaching learning system was brought up in a very short period of time. It has given impetus to the new formats of pedagogy. A tremendous initiative has been taken by academicians and institutes to promote online education. In the last few weeks, higher and technical education institutions have made significant efforts to keep pace with the situation arising out of the present crisis with flexibility. We will certainly have to work in this direction in bringing international institutional flexibility in higher and technical education. Technology will certainly play an important role in educating future generation and will play a catalytic role in bridging the digital gap in education. At the present time, knowledge is just a mouse click away because of the internet. On this occasion, I would like to appreciate and congratulate Dr. K. Samim Rani, Associate Professor and Head, Department of Zoology, for her earnest efforts in organizing this international web conference. I also appreciate the faculty members of Zoology Department for their cooperation and in making this event a grand success. I am very proud to have Dr. Samim Rani as my colleague because this is the first international web conference organized by our institution, and it will serve in a long way in motivating other departments to conduct such international conferences. I wish success of this web conference and wish everyone well. Thank you.
Thank you, sir, for the kind introduction. Next, I invite Arabic sir, Ilyas sir, to recite Quran and the meaning of the Quran verses to be recited today. Dr. Ilyas sir. Dr. Ilyas sir. Dr. Ilyas, sir.
Sir, mic close பண்ணிருக்கு.
Ilyas, sir. Ilyas, sir.
Sir, mic off பண்ணிருக்காங்க.
Just சொல்லுங்க sir.
இப்போ
Sir, mic off பண்ணிருக்கீங்க sir.
இப்போ ரைட். ஓகே. சொல்லலாம் சார்.
Ilyas, sir.
வந்துட்டாங்க.
Assalamu alaikum, sir.
Alaikum salam. Warahmatullahi wabarakatuh.
It's a great pleasure to invite Dr. Ilyas, professor and the head of the Department of Arabic, to recite the verses from the Holy Quran and the meaning of that recitation. I invite you, sir, for this web conference.
Thank you. Alhamdulillah.
Thank you, sir.
أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. الله نور السماوات والأرض. مثل نوره كمشكاة فيها مصباح. المصباح في زجاجة. الزجاجة كأنها كوكب دري يوقد من شجرة مباركة زيتونة لا شرقية ولا غربية يكاد زيتها يضيء ولو لم تمسسه نار نور على نور يهدي الله لنوره من يشاء ويضرب الله الأمثال للناس والله بكل شيء عليم صدق الله العظيم. The meaning of verse. God is the light of the heavens and the earth. His light may be compared to a neck containing a lamp. The lamp inside a crystal of a star-like brilliance, lit from a blessed olive tree, neither of the east nor of the west. The luminous oil is as if ready to burn without even touching it. Light upon light. God guides to his light whom he will. God draws such comparisons for mankind. God has full knowledge of everything. Al-Quran, chapter 24, verse 35. Sadaqallahul Azim. Alhamdulillah.
Thank you, sir, for reciting the verses from the Holy Quran. And the privilege of my principal, sir, Dr. Aslam, sir, I'd like to give a welcome address to the participants of this web conference. In the name of Allah, the Almighty, the most beneficial and merciful. Revered Principal, respected resource person, Dr. Vijay Kumar, distinguished professor from various esteemed universities, colleges in and abroad the country, my college fellow professors, research scholars, my dear students, participants, ladies and gentlemen. Very good morning and warm welcome to one and all here. It's a red letter day and a milestone in the history of Buckwood College. Max Eastman says, a smile is the universal welcome. With a smile and zeal, being the organizing secretary of this web conference, I would like to welcome the intellectual gathering through online mode. First of all, I would like to thank God who showers his blessings upon me and the institution to conduct this web conference in a grand success. May Allah bless us. The Tamil poet Ayyan Thiruvalluvar says, Neer indri iyangadu ulagam. That is, without water, world does not breathe. Like that, without biology, future cannot exist. Let me think, who is controlling the entire world now? A small microscopic organism is doing the pandemic scenario throughout the world, making all the human beings and living creatures to stand still in a mighty mysterious way. During this crisis, anything to be taken in a positive way to adopt and live in these circumstances, as Darwin told in his theory, survival of the fittest. When the entire world is so quiet, the Department of Zoology at M.S.S. Buckwood College is doing some activities to develop new educational landscape, and we have to put together on free online module. In the present scenario, the digital transformation and technological revolution has taken the key agenda for every individual sitting at their home, utilizing their laptops, mobiles as e-learning instruments to empower knowledge and soft skill through e-quiz, workshop, webinars, etc., through which God has given a wide door open to think of future. Dr. Vijay Kumar, that is the resource person of today, is a professor in the College of Science, Zulfi, Majma University, Kingdom of Saudi Arabia. Proud to say he is the son of the soil. Soil belonged to Madurai. He obtained his doctoral degree from Bharathasan University and worked as a medical microbiologist and R&D manager at the largest eye care system in the world, that is Aramid Eye Hospital and Arrow Lab at Madurai. He published more than 50 research articles in the International Peer-Reviewed Journal and published many books. He received many awards globally, such as Best Performer Award, Platinum Scientific Excellence Award, Distinguished Editor Award from DHI Publisher USA, John Sky's Memorial Award from Healthcare Society United Kingdom. He is acting as a project investigator in various funding agencies in Kingdom of Saudi Arabia. He is expert in handling proteomics and microarray techniques, mass spectroscopy, protein labeling, cDNA quantification, and gel documentation, a LISA reader, etc. His merits are innumerable. On the behalf of my college and my department, I welcome Dr. Vijay Kumar sir to take this platform and deliver and share his valuable information to the elite forum. I welcome you, sir. Welcome you, sir. Vijay Kumar sir, I welcome you for this web conference, and the platform is to you, sir. Vijay Kumar sir? Vijay Kumar sir?
Yes, irkar madam. Sir,
Yes.
mic on பண்ணுங்க. விஜய் குமார் சார் mic on பண்ணுங்க. mic off பண்ணிருக்கேன் சார்.
Okay.
Thank you.
Sir, I cannot able to share my screen.
Now. Okay, now able. இப்போ பண்ணுங்க சார் வரும்.
Thank you, Dr. Sami, for the wonderful introduction. Good morning to all. I'm going to give you a talk about health impact of airborne fungi and bacterial endotoxin exposure and respiratory infections. This presentation also covers how to identify airborne fungi and endotoxin and their control measures. First of all, I would like to thank the principal sir, Dr. Muhammad Aslam, and the management members of M.S.S. Beckford College for giving me this golden opportunity. And I also express my special thanks to Head of the Department, Dr. Shamim Rani, and faculty members of Zoology for arranging this seminar. Finally, I thank you all professors, faculties from the various colleges, research scholars, students for attending this seminar. And I also thank South Indian Microbiologist Association for their moral support. Thank you, one and all. Next, moving to our presentation. So nowadays, we are facing a difficult situation all over the world due to coronavirus disease, simply called COVID-19 outbreak. This epidemic started from China in the year of 2019 and now turns pandemic. The coronavirus are a large group of family of viruses that are known to cause illness ranging from the common cold to severe diseases like Middle East respiratory syndrome and severe acute respiratory syndrome. This pneumonia is a kind of disease. It's caused by SARS-CoV-2 virus. According to the current evidence of COVID-19 virus is primarily transmitted between people through the respiratory droplets and contact routes like nose and eyes. So we must know the kind of transmission. So mainly the respiratory infections can be transmitted through the droplets of different sizes. For example, the size is range between 5 to 10 micrometer diameter. They are referred as respiratory droplets, and the particles is less than 5 micron, they called as aerosol containing droplet nuclei. So in the droplet transmission occurs when a person is in a close contact within 1 meter distance with someone has the respiratory symptoms like coughing and sneezing. In this case, there is a high chance of exposure to potentially infectious respiratory droplets. That's why WHO and ICMR recommends to avoid the close contact. It must give at least 1 meter distance each other to avoid the spread of COVID-19. Coming to the airborne transmission, it is different from the droplet transmission as the presence of microbes within the droplet nuclei, which are generally considered to be a particles less than 5 micron in diameter, can remain in the air for a long period of time. So it can be transmitted to others over a distance greater than 1 meter distance. In analysis of 75,465 patients, COVID patients in China, the airborne transmission was not reported. So we know very well about the preventive measures and the issues facing the coronavirus. I don't want to go in detail about in this subject. Now, apart from this new pandemic, we are facing a lot of other airborne infections caused by bacteria, fungi, and their toxins. So this is a right time to think about and to study about recall the health effects due to other airborne microbial particles like bacteria and fungi. So in this seminar covers the following topics: airborne fungi and their sources and identification of fungi, and airborne endotoxin and medical risk of exposure of fungal spores, endotoxin and respiratory infections, and finally end up with control measures. So what is airborne infection? So air can act as a carrier of any pathogen that is airborne. Even though the air is not a suitable medium for growth of pathogens, the original source of pathogen can be coming from either humans or soil, plants and animals. So microorganisms are suspended in the air and can be carried over even a long distance from the source. Dust is also important carrier of airborne disease agent. The pathogen can be transported within the droplet nuclei. A pathogen can survive for relatively long period of time in or on dust particles. So thus diseases are caused by these pathogens are called airborne infections. Most of the airborne microbial diseases involves respiratory infection. So the definition of the bioaerosol, it is a colloidal suspension formed by a liquid droplets and particles of solid matter in the air. These particles suspended in the air, and it may consist of a bacteria, fungi, viruses, and fragment of bacteria and fungi like cell wall, DNA, and their metabolic products, mycotoxins, endotoxin, plant pollen, plant tissues, fragments, all are these suspended in the particle. So this is called bioaerosol. This reports 34% in indoor air quality. In addition to this, air pollution from dampness and molds, chemicals, and other biological agents is one of the most public health problems, with increasing the importance due to the adverse health effects on humans, animals, and plants. Since in the 2010, Bengaluru University has been monitoring bioaerosols in the form of bacterial contamination and fungal spores in the air. They reported that the annual average number of bioaerosols ranged between 64,000 CFU per cubic meter in the year of 2014 and increased in the year of 89,000 CFU per meter cube in 2016. Even though this is higher than WHO recommended limit, which is 10,000 CFU per meter cube for indoor environment. So the risk of bioaerosols can become a serious risk to the health population, mainly because of airborne bacteria and fungi can cause infectious diseases as well as allergic, asthma, and toxic effect. So in this seminar cover airborne fungal spores and endotoxin. So airborne fungal sources. There are four main sources we frequently exposed: outside air and indoor, which including home, working places, shops, etc., and hospitals. Most of outbreaks of nosocomial fungal disease have been attributed to airborne fungi from the sources outside of the hospital. And also the fungi coming from the plant debris, also important source. Coming to the fungal load versus risk. The various study reported 100 to 600 species of fungi isolated from the samples collected from the indoor environments. At the same time, approximately 100,000 species reported from outdoor environment. These fungi are mainly belongs to the family of deuteromycetes, mucorales, ascomycetes, and wood-rotting basidiomycetes and some yeast. However, the exact number of fungi still remains unknown. At the same time, the abundance of airborne fungal spores in outdoor air vary from place to place, and it influences mainly by climatic conditions and human activities. In the case of indoor environment, indoor air pollution is a major responsible factor for severe illness and deaths compared to the outdoor pollution, because we are majorly time spent in the indoor environment. As per WHO report, indoor air pollution has caused approximately 2 million deaths in developing countries and has been found to be responsible for 4% of global disease burden. Indoor fungi, by growing them in building material, foodstuff, flower pot, and bedding material, house dust, etc. So in suitable condition reaches, these fungi grow and sporulate in various substrates and constitute a significant sources of airborne fungal conidia and hyphal fragments in indoor environment. So a comprehensive checking of fungal contamination in the indoor environment is very important. So we should consider the following factors like outdoor air, then air conditioning, heating, ventilation system, ventilation mode, heating, occupancy density, relative humidity of the air, dampness, and maintenance of any water leakage. We have to consider all these factors. If possible, we can perform air sampling or surface sampling to check the microbial load indoor environment and find the fungal organisms and to take the corrective and remedial actions. So these are the predominant fungal area observed in indoor environment are Cladosporium, Alternaria, Aspergillus, and Penicillium. There are many reports available worldwide in indoor fungal flora. Among them, we will see some interesting results which we face our routine life. First, the millions of fungi present in our bedrooms, especially on pillows. So there is one study by Woodhook et al. Reported that the pillows contains a substantial load of many species of fungi, particularly Aspergillus fumigatus. This is one important fungi causing invasive fungal aspergillosis. And this study also reports the old pillow contains approximately 1 million fungal spores. This is very huge number. And Taiwan researchers conducted another study in the classroom across 44 schools and reported that predominant fungal flora are Aspergillus, Penicillium, and Basidiospores, which are significantly associated with childhood asthma and allergies. They suggested that government health policy should explore the environmental interventions for the elimination of fungal spores in classroom to reduce the prevalence of childhood asthma. So there are many studies reported in last 2 decades in various indoor environments. In India, the fungal survey has been reported several cities across the different geographical region, and the dominant fungal flora are reported Cladosporium, Penicillium, Aspergillus, Curvularia, Fusarium, and Alternaria. And another study from Saudi Arabia, the abundance of fungal load in outdoor environment is high, and they analyzed the samples from sandstorm dust, which is frequently hit in the desert environment. So they analyzed the sandstorm dust sample and found that Alternaria, Aspergillus, Botrytis, Cladosporium, Mucor, Eulacladium, Fusarium in the sandstorm dust samples. So all these fungi mainly cause a potent allergen, and this may cause a reason for highest incidence of asthma among the communities living in the desert impact areas, particularly in the Middle East and Caribbean deserts. Similarly, many reports available for the outdoor fungal survey and predominant fungal flora are the same as we discussed before. Okay, how to qualify the indoor environment? Is there any accepted limit of fungi is available? Yes. As per the available guidelines, the maximum fungal count allowed 750 per cubic meter cube. So this is recommended by Healthy Building International Standard. And also other standards like Indoor Air Quality Association and National Health and Welfare Canada Association, all are recommended the fungal count should not more than 300 or 500 CFU. And all the standards recommended there is none of allergenic fungi. If you find any allergenic fungi in your indoor environment, you must take immediate corrective action and evacuate from that particular place. So now next we move to the airborne endotoxin. Endotoxin, an important biological components of airborne particulate matter, and it is very active lipopolysaccharides, which are cell wall components of outer membrane of gram-negative bacteria. The endotoxin also referred as a pyrogen for its fever producing effect, and it is available present in outdoor and indoor environment. It is thermostable in nature, not denatured by autoclaving. It can be removed by depyrogenation process only, which is heat treatment of more than 260 degrees Celsius for 60 minutes. So endotoxin testing is very important test for the parental drug manufacturing industry, because if the endotoxin limit exceeds in the parental drug, it causes fever, inflammation, chills, shock, hemorrhage, and even finally death. So, what are the airborne endotoxin sources? The endotoxin is found is high concentration in the air at sites that handle the organic materials such as composting sites, intensive farm, and wastewater operations. Occupational exposure to endotoxin from such sites was previously reported by many authors. Why we to worry about the airborne endotoxin? Because we inhale the endotoxin, it linked to various health outcomes. For example, it causes fever, headache, wheezing, and nose and throat irritation. And exposure to endotoxin hello hello
சார் பேசுங்க சார்.
somebody okay.
இப்போ பேசுங்க சார்.
Okay. Exposure to endotoxin in the home and outdoor environment.
ஸ்கிரீன் ஷேர் பண்ணிடுங்க சார். அது வரல இன்னும் பவர் பாயிண்ட்.
One minute.
Okay.
Is it okay? Yes. So why we worry about airborne endotoxin? Because inhaled endotoxin is linked to various health outcomes. For example, it causes fever, headache, wheezing, and nose and throat irritation. And the exposure to endotoxin in the home and outdoor environment causes airway inflammation, toxin, pneumonitis, and mucous membrane irritation, asthma, and allergic diseases. So what is the acceptable endotoxin exposure limit? Even though endotoxin is more widely associated with the negative health outcomes, only few standards are available, and there is no exposure limit for endotoxin. However, the Health Council of Netherlands suggested the endotoxin limit for occupational health workers. It is 90 endotoxin unit per meter cube. It is for 8-hour exposure. At the same time, they recommended 30 EU per meter cube exposure limit for general public, which is 3 times lower than the occupational health limit divided by uncertainty factor 3. So this is due to the lack of understanding as to how to discount the averaging time used in occupational health limits for the general public. So coming to the ambient air endotoxin analysis, characterization of ambient concentration of endotoxin is important for evaluating the impact of potential sources such as waste site and intensive farms. As we know very well, the proposed threshold limit is 30 EU per meter cube for the public. So all over the world, the mean and median concentration of reported endotoxin limit was 0.006 to 5.7 EU per meter cube, and the highest level of endotoxin observed only in urban areas. In China, they conducted study and they reported 75 EU per meter cube, which is higher than the occupational safety level and in the Beijing city. So unlike fungal data, there are very limited reports available about endotoxin levels in ambient air. The reports from Canada, Chile, Germany, USA, China, Taiwan. And overall, the mean and median concentration reported in the literature 0.006 to 5.7 EU per meter cube. Unfortunately, there is no standard available so far from India. So the environmental microbiologist or toxicologist may consider this subject for your future work. Then endotoxin so in composting facilities, The composting can impact ambient endotoxin concentration, which is similar to the dispersal pattern to the viable bioaerosols. The endotoxin measurement at a source are highly variable, ranging from 0.56 to 18,000 EU per meter cube. Sykes et al. Reported that manual sorting and shredding process of the waste resulted in highest endotoxin exposure for the employees, which is 86.11 EU per meter cube. And when compared to the normal areas, it's 23.48. So it is important that the impact of activity is considered when accessing the emission of environment is subsequent exposure to the nearby residents. The employee working in the outdoor composting facilities were exposed to the higher endotoxin concentration when compared to the indoor workers. This may be due to the higher indoor humidity affect the endotoxin level. So overall, this highlights the potential nearby communities to affected by outdoor operations, especially as endotoxin may be easily dispersed and remain in the environment. Because it is thermostable in nature, it remains over a period of time, whether the agents in the bioaerosols are viable or not. The next discuss about the airborne endotoxin level in intensive farming. The various studies reported in USA, Germany, Netherlands, and Switzerland analyzed the endotoxin concentration in swine, poultry, and cattle farms. The mean on-site ranged from 1.6 to 2,576 EU per meter cube. As per the literature, the people in rural areas are likely to be exposed to the higher endotoxin concentration than those in urban areas, because this is due to the intensive farming in their regions. Very high concentration of endotoxins, nearly 98,000 of 990 EU per meter cube, were observed in the swine farm workers. Then in the other farm, in poultry farm, reported 83,640 EU per meter cube. So as per the available report, swine farm workers were exposed to higher endotoxin concentration than other farm workers. So there is one report from India, Gangama et al. In the year of 2011. It is a first report on the concentration of the characterization of airborne biological particles on 6 wastewater treatment plants in Mumbai. They reported the mean range of endotoxin limit in wastewater treatment plant was 0.8 to 741 EU per meter cube. I hope you understand the levels of fungi and endotoxin in various environments. So now we will move to how to collect the samples to identify the airborne fungi and endotoxin. First, we will see the air sample collection for microbiological sample analysis. For microbiological analysis of fungi, you can use either malt extract agar or sabrodextrose agar or potato dextrose agar. All air samples collected using passive air sampling or active air sampling. Passive air sampling is nothing but the exposure of the media filled petri dish in particular duration in outdoor environment, roughly 30 minutes to 4 hours. And active air sampling is by collecting the sample by microbiological air sampler, which is quantitatively collect the volume of air. So we can give the exact microbial load per 1,000 liter of air sample. And after that, the culture plates incubated 20 to 25 degrees Celsius for 1 to 2 weeks. And here, very important point is identify the fungal organisms based on their colony and then spore morphology. So there are 4 basic techniques used for the identification of fungi. It is to take the direct portion of the colony, or we can use the adhesive tape technique and slide culture technique. The adhesive tape technique and slide culture technique, we can get the clear picture of colonial structure and microscopic morphology for easy identification. Lactophenol cotton wool staining used for the identification of fungi. So after staining process, the identification of fungi is a very crucial step. So here I would like to mention here, I compared the microscopic pictures of airborne fungal spores with common materials which we are routinely everyday using for comparison purpose for easy understanding. I hope this will be easy understand to all like undergraduate or postgraduate students. So based on the colony morphology, the fungi are categorized in the two types, like hyaline or demataceous fungus. The hyaline fungus, no melanin pigment, but in the case of demataceous fungus, is also called black fungi. It contains melanin in their cell wall. So their colonies are dark black color. And in the case of hyaline fungus, they are different colorful colonies. So coming to the first fungus, Aspergillus. So Aspergillus niger, it gives black colored colonies, and conidial head are largely radiated. It's like a sun. The Aspergillus fumigatus gives bluish green colored colonies on potato dextrose agar, and if the microscopic morphology of the spores, it gives typically columnar conidial heads. It looks like a flame. Aspergillus flavus, it gives greenish yellow colored colonies. The conidial heads are radiated. The difference between Aspergillus niger, here the Aspergillus flavus are small, but the radiation in Aspergillus niger is big, and also the colony also, based on the colony morphology, we can easily differentiate. And Aspergillus teres, it gives sandal yellow color to brown colored colony, and the conidial heads are biseriate. So next fungus, Penicillium. So remember the Penicillium, it looks like a brush or broom-like structures. So the colonies of the Penicillium gives green to blue color with a white or yellow margin, and it gives the branched conidiophores and metulae phyllates arranged, and finally it looks like a brush-shaped structure. The next fungus, Fusarium. So you remember it looks like a banana or boat-shaped structure. So for easy identification, so these spores, it looks like this. The spores are like a boat-shaped structure. The Fusarium produces two kind of spores: microconidia and macroconidia. Macroconidia looks like a boat-shaped structure, and Fusarium, it gives like white, cream, or yellow to red colored colonies. Depends upon the species. And in the macroconidia are unbranched, and it is two-celled and thick, and it is a sickle shape, like boat shape. So the rhizopus are giving cottony kind of colonies. It is a very fast growing fungus, and within 3 days it covers the entire surface of the media. And in my microscopic morphology, you can easily differentiate based on the rhizoids, the root-like structures, and it is sporangiospores producing fungi. It is very similar to many of them. They confused about the rhizopus and mucor. We can easily differentiate rhizopus and mucor. The mucor, no rhizoids, and single conidiophores or sporangiospores are present. But in the case of rhizopus, a tuft of sporangiospores are present, either 2 or 4. So moving to the demataceous fungus. We already discussed demataceous fungus are melanin pigment present in their cell wall, so it looks like a dark brown colored hyphae and spores. This melanin pigment causing the virulent nature. So the Xerohilum bipolaris Drusularia. All three fungus very similar structure. The microscopic morphology is very similar, and it looks like a bean-shaped structure. You remember the bean-shaped structure. For the Xerohilum, it gives the long proconidia with the cylindrical and ellipsoidal shape, and with the protuberant hilum at the base. And the colony morphology is dark olive to black color colonies. Bipolar is also same, but the length is very small compared to the Xerohilum, and also it produces simple and branch zigzag arrangement, two-sided zigzag arrangement. And Drushlaria, you just remember this Drushlaria, it looks like a baseball bat shape, and the conidia are transversely septate. So these three fungi structurally similar with the small modifications. And moving to the next fungi, Curvularia. Curvularia, its name itself mentioned Curvularia, it's a curve in shape. So the central cell, the typically darker and enlarged when compared to other ant cells, and it is curved appearance. The colony, it's gray color, black to gray color. So the next fungi, Alternaria. So you remember this figure? This gives like beak or shape. So here the Alternaria, it's like beak shaped structure. This structure is called muriform structure. The colony is greenish black to olive color. Then Eulacladium is a dementatious fungus, and this color is olive brown to black. And there is one difference between Alternaria. There is no beak-like tapered apex in Eulacladium. Then moving to next fungi, Cladosporium. It is a shield-shaped appearance. The colony looks like dark green and black colored appearance, and the conidia are elliptical, cylindrical in the form of chain, the shield-shaped conidia. And another interesting fungus, Phialophora. It looks like flower wash shape, and it gives unicellular, hyaline, brown, smooth, round, oval, cylindrical conidia, and the phyalides looks like flower wash shape. The last fungus, Lacia diplodia. The another name is called Botrytis diplodia. This the spores, it looks like a small coconut. You remember the coconut, so you can easily identify this fungi. It's called another name is called Botrytis diplodia theogram. This is a common plant pathogen. It causes the rot disease in banana and guava. So overall, we identify nearly 20 different kind of fungus, and among these, there are many potent allergens are present. So moving to the endotoxin sampling, the endotoxin sampling collected by the passive air sampling, exposing the electrostatic cloth in the outdoor environment, it allows to settle for airborne particles. More particles absorbed due to the electrostatic nature of the cloth. After a particular duration of time, the 24 hours, the cloth removed and choked in endotoxin-free water. The nature of endotoxin-free water is highly water soluble, so Vortex the content, and this will take it for further analysis of endotoxin determination. Similarly, active air sampling is performed by the vacuum suction kind of machine. It's called air sampler. Here the air samples the sucked from the environmental air in the particular flow rate, like 2 liter per minute or 100 liter per minute. So we have to assemble 0.45 micron polycarbonate filter for sampling. After sampling, the constant flow rate is maintained a period of 8 hours up to week time. Once the after sampling, take the filter and remove the extract the endotoxin as the same method discussed in the passive air sampling. So the endotoxin testing by LAL test method, this is a simple method developed by Dr. Bang and Levin. A simple concept in this method, the endotoxin react with the blood of horseshoe crab. It gives a clot formation. And this is very faster and economical, more sensitive than rapid pyrogen test. And the LAL meaning is the limulus. It means the horseshoe crab, and amoebocyte. Amoebocyte means it is an active component is derived from the crab blood cell, and lysate is the component is obtained by separating amoebocytes from the plasma and then lysing them. So there are three common methods used for endotoxin testing. The first one is gel clot method. So we can qualitatively analyze presence or absence of endotoxin in particular level based on the formation of gel clot. And turbidometric method, chromogenic methods, or quantitative method. In turbidometric method, either the rate of increase the turbidity or the time taken to reach the particular turbidity is measured spectrophotometrically and compared to the standard curve. In calorimetric method, the endotoxin catalyzes the activation of proenzyme in LAL, which cleave the colorless substrate to produce a colored end product, which can measure spectrophotometrically and compared to a standard curve. This is the kinetic endpoint method. The overall, the endotoxin levels expressed as generally U per meter cube. So moving to the medical risk of airborne fungi and endotoxin. So infectious diseases caused by inhalation of fungal spores depends upon the biological and chemical properties and number and size of the fungi inhaled and the site of their deposition in the respiratory system is very important. For example, the size is greater than 10 micron. For example, the pollens deposited in the nasopharynx and causes allergic reactions called hay fever. If the size 5 to 10 micron penetrate into the lower airways and cause asthma and allergic diseases. If the fungal spore size less than 5 micron, for example, Aspergillus fumigatus, the spores are 2 to 3 micron size, are able to penetrate in deep alveoli and capable of causing pulmonary infections in human. So overall, the fungal exposure leads to causing respiratory allergies, infectious asthma and allergic bronchopulmonary mycosis, superficial skin infections, allergic fungal sinusitis, and hypersensitivity pneumonitis. Inhalation of fungal spores highly risk to the school children. If they live in damp and moldy environment, there are high numbers of airway symptoms like coughing, sneezing, and sore throat and runny nose. And children exposed to the higher level of molds are at increased risk of persistent cough. In addition, Aspergillus and Penicillum DNA have been positively correlated with wheezing. If the patient exposed with excessive fungal exposure will have the following complaints and symptoms. For example, headache, runny nose or nasal congestion, burning sensation, watery eyes, sore throat, sneezing, unusual nosebleeds, and skin and mucous membrane irritation, dizziness, concentration and memory problems, and severe fatigue and exhaustion, nausea and feverish feeling, and joint and muscle pain. So moving to the fungal respiratory infection. The respiratory tract infections are globally responsible for 1/3 of infectious diseases associated with mortality and accounting for 4.3 million annual deaths. Among these, fungal infections of the respiratory tract are largely unrecognized and the true burden is indescribable. Even though the treatment of most invasive fungal infections are associated with high mortality rate is greater than 50%. In general, the fungal infections of the respiratory tract are considered also called invasive pulmonary infections caused by Aspergillus species and some other mucorales like Mucor and Rhizopus. However, over the last 10 years, a number of uncommon filamentous fungi such as Cladosporium, Fusarium, Penicillum, melanized molds, and basidiomycetes have emerged as etiological agents of well-characterized respiratory disorders. So, here the question is, who gets the fungal infections? Anyone can get fungal infections because fungus are common in the environment. So, people breathe in and or come in contact with the fungal spores every day without getting sick. However, people with weak immune system, these fungi are more likely to cause an infections. So what weakens the immune system? So some people are born with a very weak immune system, and others may have like illness that attacks the immune system. For example, HIV positive patients. Some people hospitalized for a long time, or organ transplant patients, or stem cell transplant patients, cancer patients, or weakly immune. Some medications like corticosteroids or cancer therapy can also lower the body ability to fight against infections. So these people are highly prone to get fungal infections. The fungal infections can also affect the healthy people. Yes, the fungal infections that are not life threatening, the infection in healthy people, such as like skin and nail infection and vaginal yeast infections are common. Some infections are more serious. For example, the lung infections like histoplasmosis. This is the histoplasmosis infections due to the dimorphic fungi. This fungi present in the birds' feces samples, um, and uh, uh, and this is predominantly present in the soil region of particularly in eastern and central region of USA. So there is another concern about airborne fungi. Another infection, airborne fungi by yeast, is the Cryptococcus gattii infection. So Cryptococcus gattii this is a variety of neoformans, and it lives in the environment usually near the trees and the soil around the trees. So it is present in the region of British Columbia, Australia, New Zealand, and United States of Pacific Northwest, like Oregon and Washington. The infection caused by inhalation of dried yeast cells or spores. Cryptococcus gattii travels through the airway and enters the lung, and also it enters the bloodstream to cause to infect other areas of the body, particularly in the brain. So if the infection in the lung, it caused pneumonia-like illness. The symptoms of this pneumonia, cough, shortness of breath, and chest pain, fever. And it moved to the brain, it caused meningitis. Symptoms are headache, fever, neck pain, nausea, vomiting, and sensitivity to the light, and confusion or changes in the behavior. The incubation period for this fungi, after breathing the fungus, it takes 6 to 7 months to show the first symptoms. In some cases, takes 3 years time. So who gets infections? As per the report, Australia and New Zealand, even healthy people only get infected for this infection. At the same time, the report from Canada and British Columbia, they also reported the weakened immune people also infected this yeast. And this is not transmitted from one person to another. So moving to the very important important respiratory airborne fungal respiratory infections, Aspergillosis. Aspergillosis is an infection caused by Aspergillus, a common mold that present in the indoor and outdoor environment. The Aspergillus fumigatus is the most common cause of human Aspergillus infections. The other species like Aspergillus flavus and Aspergillus teres and Aspergillus niger, and most people breathe in Aspergillus spores every day without getting sick. However, the people with weakened immune system or lung disease are highly prone to develop the disease. So the type of health problems caused by Aspergillus species include allergic reactions, lung infections, and infections in other organs. Types of Aspergillus infection. So there are several types. The first one is allergic bronchopulmonary aspergillosis. It's called ABPA. Here, the Aspergillus causes inflammations in the lungs and allergy symptoms such as coughing and wheezing, but doesn't cause any infection. And allergic Aspergillus sinusitis is the inflammation in the sinuses and the symptoms of sinus infection like drainage and stuffiness and headache, but doesn't cause infection. Then aspergilloma. So it is a ball of Aspergillus grow in the lungs or sinuses, but usually does not spread to the other parts of the body. So this is also called a fungal ball. And chronic pulmonary aspergillosis. Aspergillus infection causes cavities in the lung and can be a long term, 3 months or more. One more fungal balls may also be present in the lungs. Then invasive aspergillosis. It is a serious infection and usually affect the people who have weakened immune system, such as the people done organ transplantation and stem cell transplantation. The invasive aspergillosis most commonly affect the lungs, and it can also spread other parts of the body. And cutaneous skin aspergillosis, it occurs when aspergillus enter the body through the break or the skin, for example after surgery or a burn wound, and cause infection, usually in people who have weakened immune system. Cutaneous aspergillosis can occur if invasive aspergillosis spreads to the skin from the somewhere else in the body, such as lungs. So nowadays, this is we are facing issues with COVID-19. There are some reports, very recent reports. The pulmonary invasive aspergillosis also the co-infection with COVID-19. Only the few reports available in this kind of scenario. There is one report from Austria. The 70-year-old male diagnosed COVID-19, and after that they affected by pulmonary aspergillosis. So they suggested that the screening studies are needed to evaluate the prevalence of invasive pulmonary aspergillosis in COVID-19 patients admitted to the ICU. So the next, moving to the another airborne fungal infection, mucormycosis. Mucormycosis, it's previously called zygomycosis, is a serious but rare fungal infection caused by a group of molds like Rhizopus, Mucor, and Rhizomucor. This fungus present throughout the environment, air, soil, in association with decaying organic matter like leaves, compost piles, or animal dung. And it is most commonly affect the sinuses or lungs after inhaling the fungal spores from the air. And sometimes the skin after the fungus enter the skin through a cut or a burn or other type of skin injury. However, it can occur nearly any part of the body. So it is a serious infection that typically affects the people with weakened immune systems, such as the people who had an organ transplant surgery. And mucormycosis is frequently a life-threatening infection. A review published about mucormycosis, and they reported the mortality rate is 54%. The mortality rate varied depending upon the underlying patient condition, for example, type of the fungus and body's site affected. For example, the mortality rate 46% among the people with the sinus infection, and 76% for pulmonary infections, and the 96% for disseminated mycosis. So apart from Aspergillus and Mucor, there are some black fungi also cause opportunistic airborne infections. The most melanized fungi that cause the infections are free-living plant subrobes and implanted into the human tissues as a result of trauma. But respiratory mycosis occur the secondary to inhalation of fungal spores. For example, Alternaria species, bipolaris, Curvularia, and Xeroscylum are associated with allergic fungal rhinosinusitis and bronchial asthma, hypersensitivity pneumonitis, and allergic bronchopulmonary mycosis and invasive lung disease. So how to avoid the fungal exposure? So try to avoid the direct contact with if the persons are weakly immune, try to avoid the contact with the waterlogged buildings during the raining time or hurricanes or natural disaster, and avoid activities that involve close contact with soil and dust. while gardening, and wear shoes and long pants and long sleeve shirts when doing outdoor activities such as gardening and visiting other areas, wooded areas, and wear gloves and mask when handling the materials such as soil and mosses and manure, because it contains more fungal spores, and to reduce the chances of developing skin infections, to clean the skin injuries well with soap and water, and especially if they have been exposed to the soil or dust, and maintain good air quality system and good hygienic practices. So the take-home message is the airborne fungal exposure causes serious health effects to the weakened immune people. The excess airborne endotoxin exposure causes allergic reactions to healthy people, and need more studies in our local environment, and we have to maintain the global air quality in indoor to avoid unnecessary fungal exposure. So avoid fungal exposure, stay healthy. And thank you one and all, and thank you to management team of M.S.S Webport colleges for giving me this golden opportunity. Thank you one and all.
Madam. Now question answer session. Anybody have a question? Ask our resource person.
Srinivasan, sir.
Okay, madam.
The question is in chat box, sir.
Okay, madam.
Sir, if I want to ask one question to Vijay Kumar, sir.
Yes, ma'am.
What is the role of fungi in this environment as a complication in COVID-19 infections, sir? As far as that is Kingdom of Saudi Arabia is concerned, or in Wuhan?
Yes, ma'am.
It's,
yes,
or
ma'am.
in,
This is a very interesting question
okay.
because we know very well about COVID-19 infections. It mainly infect the high chances of infecting of old age people and the weakened immune system. Even with the COVID-19 infections, their immune going to work. This also cause easy infection from the environmental fungi. And recently in China, they analyzed based on their environmental conditions like indoor air quality and wetness. The people living in that area and they affected COVID, they are getting high chances of fungal infections also.
Okay. It spreads through spores or allergens, is it not, sir? Which cause mycotoxins?
Yes. Yes.
Okay. Okay. Yeah, I've mentioned about the pulmonary Aspergillus, is it not, sir?
Yes.
I came through an article that
Yes,
is in France, 9 patients has been affected by invasiveness of Aspergillus.
Yes.
So what is the role of Aspergillus in our lung system, sir, respiratory system? Is any test is made to prove the invasiveness of Aspergillus?
You mean to detect the invasive Aspergillus or what
Yes.
kind of?
Yes. Invasive pulmonary Aspergillus.
So invasive pulmonary Aspergillus based on the X-ray, then we have to collect the sputum samples and X-ray and biopsy samples. Based on that, we can and culture we can to detect the Aspergillus
Okay. Any specific test that's just like RCPR, PCR, or ELISA? Is any specific test? Yeah.
I couldn't catch your question, ma'am. Could you please
Yeah.
repeat once again?
Okay. Is it to identify the invasive Aspergillus, pulmonary Aspergillus? Is there any
Yes.
specific test?
Actually, there is one test called galactomannan testing, ma'am. So it is available, and this test, it's a lot of research is going on to identify this Aspergillus, pulmonary Aspergillus with COVID patient.
Okay. And persons have asked a lot of questions in the chat box.
Yes, ma'am.
One person from Nias from Madurai Vakport College, he asked, what is histoplasmosis? He has asked.
So histoplasmosis, it's actually it is caused by the fungus histoplasmosis is a dimorphic fungi. Histoplasma capsulatum is a dimorphic fungi. It is commonly present in the sulfur-rich soil in the area of central region of America, and this also the the birds droppings and bats droppings also contains high spore contents of histoplasmosis. It is present in the soil, and if while working the gardening, at that time the spores are inhaled to the through the lung route and cause the infection. And it is dimorphic fungi, and it is a highly pathogenic fungi. This is not
it's a highly pathogenic. Okay. Which is the highly pathogenic fungi for humans?
All dimorphic fungi are highly pathogenic, like histoplasma capsulatum and Coccidiomycosis and Sporothrix. All dimorphic fungi are highly pathogenic. Even it infect the normal healthy patients also. But at the same time, even though the normal flora of fungi like Aspergillus and Mucor, it is present in the common air, it is not a danger, but it is highly danger for the weakly immune people.
Okay. Okay. A lot of questions has been put in YouTube chat box, sir. Let I select one question. That is Jasmine Shahana. She's asking, is it possible to identify all fungus which is cultivable in our lab without sequencing? Is there any database available which helps in identification?
Actually, based on colony morphology and spore morphology, it is very difficult to identify up to the species level. We can say up to the genus level only. Based on colony morphology, we refer, and then microscopic morphology, we can identify the genus level. But nowadays, there are many fungus are emerging. Every year, 1,500 new fungus are emerging. So, maybe the species level is very difficult.
Okay.
Sir, on your video, sir. Presentation இருக்கு கொஞ்சம் வீடியோ ஆட் பண்ணி.
Vijay Kumar, sir.
Yes, ma'am.
Another question, Dr. Durai Kanu. Why aerosol transmissible disease are increased compared to the city? ADT. We used to call us ADT, is it not?
What city?
Why aerosol transmissible disease, ADT, aerosol transmissible disease, are increased compared to city?
Because the city are more polluted when compared to the rural areas, and the rural areas are more ventilated, and the congestion of people and pollution and the dust particles, this carrying more fungal particle when compared to the rural areas. So this is maybe the one of the chance for getting high fungal infection in urban areas. And so we have to study the more studies in our environment to analyze the fungal profile, like heavily trophic areas and heavily with the public gathering places. From that, we can have some basic baseline data to aware the public.
The last question, sir, can I ask?
Yes, ma'am.
What is the normal limit of endotoxin exposure in India setup, sir?
Actually, in Indian, there is no normal guidelines available in India because the lack of studies in India. And as I mentioned in the presentation, only one study is available in India, and they conducted in the wastewater treatment plant environment. So the direct answer is there is no standard is available so far, and as per the Netherlands standard, we can consider like 30 endotoxin unit per meter cube for resident people, or and 90 endotoxin unit for the healthcare. Sorry, the persons working in like farming industries or composting industries.
Vijay Kumar sir, so thanks of you. Your presentation on bacterial endotoxin and respiratory infection and different types of fungi identification is awesome. And your presentation and the animation is excellent. And they are mostly the students and the research scholars and even the professors from microbiology, biological science, they'll be benefited more. And we got a lot of information from you from the international standard and how it affects our respiratory systems and all. So thanks of you, sir. And we had a nice interaction. You answered almost all the questions asked by the students. And some professors from Bangalore and from Ethiopia, she asked some questions. And many of participants from YouTube, more than 100 participants from YouTube, thanks, conveyed the thanks for you, sir. And
Thank you so much.
thank you. And I want to ask my principal to say some words about this presentation. I invite my principal
for giving me this golden opportunity, ma'am.
Okay, thank you. Awesome, sir. We learned many things, many information from you.
Thank you so much.
So, principal, sir, just say a few words about.
The session was highly informative from a biological perspective. Under the current, we are all in a situation where a virus is threatening the world. So it was a very good topic, and the session was highly useful to all the participants. I thank Dr. R. Vijay Kumar on behalf of Mukesh Shah Sir, Board College, for accepting our invitation and giving a very nice presentation. Thank you, sir. Thank you very much. And I also congratulate Dr. K. Shamim Rani, Associate Professor and Head of Zoology Department, for taking pains to arrange this first ever international web conference from our platform. Thanks one and all.
Okay. It's my time to end the session, and I'd like to convey my vote of thanks. It's my great privilege to deliver the vote of thanks. First of all, I'd like to thank the Almighty, who has given power and strength to organize an international web conference during this pandemic period and keep all of us safe. It's my bound duty to thank my principal, sir, who immediately gave permission to do this function in a successful manner. Thank you, sir. It's a great honor for me to thank the resource person, Professor Vijay Kumar, sir, readily accepted my invitation without any hesitation to perform this webinar in a great successful manner, and a wonderful session we had it, sir. Thank you, sir. I feel pride and proud to convey my gratitude and thanks to my alumni of this college, that Mr. Saravanan and Mr. Fahad, who were the backbone of this seminar. And he studied, both of them studied BSc Zoology, microbiology, and they are the first set to me. Thank you, Fahad, and thank you, Saravanan. I would like to thank the technical assistant, Dr. Srinivasan, sir, who prepared the webinar link through Zoom platform. I'm in depth to thank my staff members, in assisting to conduct this international webinar throughout the presentation. I'm always gratitude to my institution and my senior professors in the department, because my department is the Starboard department, and it's my bound duty to thank my former HOD, Professor M. Mohammed Salim, who showed the right path to achieve my destination in my academic endeavors. Thank you, sir. He brought me to this level, sir. Thank you, sir. Last but not the least, without participants' involvement, we cannot make this webinar in an effective and a successful manner. And once again, I thank all the participants from in and abroad. The participants has taken place in this webinar, and among that, few from Kingdom of Saudi Arabia and Oman, and from Ethiopia. I think this is the first time in the history of Buckboard College the foreign participants are taking place in the conference. And once again, thank this, my principal and my faculty members and all my friends dear and near, and especially to my principal and Vijay Kumar sir. So thanks of you, sir, Vijay Kumar sir. Once again, we'll meet again, and the son of the soil, the Madurai, and it'll be pleasure to come to my college, sir. Thank you, sir.
Sure, ma'am. Sure.
Thank you, sir.
Thank you so much, ma'am. Thank you.
Thank you.